Hello everyone, today we'll discuss about acid-base balance. Now, what is acid-base balance and what is its importance? As we all know, all the physiological activities they depend on the acid-base status of the body. In our body, acids are continuously produced and acid production is balanced by the production of bases and which regulates acid-base balance. Now, what is acid? In simple term, acid is a proton donor and base it is a proton acceptor. Now, what do we mean by strong acids, strong bases, weak acids and weak bases? Strong acids, they are the acids having strong tendency to donate protons. For example, hydrochloric acid, sulfuric acid, etc. Weak acids, they have weak tendency to donate protons and they are like carbonic acid H2CO3. Strong bases, they have strong tendency to accept proton like chloride ions. Weak bases, they have weak tendency to accept proton like bicarbonate ions. Now, let us start with H plus ions and pH. H plus ions, they have only one proton and this proton is highly reactive. Now, normal H plus ion concentration, that is about 38 to 42 nanomoles per liter. Now, pH. What is pH? It is the scale used to find out H plus ion concentration. The scale is from 0 to 14. Water has neutral pH. It is about 7. Now, how to calculate pH? pH is equal to minus logarithm of H plus ion concentration. If we talk about water, in water, when we are placing this formula that pH is equal to minus log H plus ion concentration, that is 10 raised to minus 7 and therefore pH of water, that is neutral, 7. Now, as we all know, pH is equal to minus logarithm of H plus ion concentration, means when H plus ion concentration increases, pH decreases, which is known as acidosis, and when H plus ion concentration decreases, that results in increase in the pH, which is known as alkalosis. Let us discuss pH of various fluids. Blood pH is about 7.38 to 7.42. pH of saliva, that is 5.4 to 7.5. Gastric juice pH, that is about 1.5 to 3.5. It is least because of highest amount of hydrochloric acid in the gastric juice. pH of bile, that is 6 to 8.5 and pH of urine, that is from 4.5 to 8. Indirectly also, pH can be calculated from Henderson-Hasselbalch equation. Now, what is this Henderson-Hasselbalch equation? It uses the components of H2CO3 and HCO3 minus ions in the system and that is used to calculate pH. What is the equation? Let us discuss first here. Henderson-Hasselbalch equation, it is pH is equal to pK plus logarithm of HCO3 minus ion concentration divided by H2CO3 concentration. Now, let us discuss how this equation has come. H plus ions, they combine with HCO3 minus ions and they form carbonic acid H2CO3. So, you can say that concentration of H plus and HCO3 minus ions, that is proportionate to carbonic acid. Okay. So, now when we are doing the mathematical calculation, you can say that H plus concentration is directly proportionate to H2CO3 concentration divided by HCO3 minus. Here we place this HCO3 minus below this one. Okay. Using this formula in the equation, we will get that H plus ion concentration is equal to K. K is a constant plus H2CO3 concentration divided by HCO3 minus ion concentration. Now, we add logarithm. So, log H plus ion concentration, when we are adding minus log, we are including minus log on both the sides. So, minus log H plus concentration is equal to minus log K minus log H2CO3 divided by HCO3 minus. Okay. When we are changing the sign from minus to plus, we are changing this numerator and denominator. So our equation becomes logarithm of HCO3 minus ion concentration divided by H2CO3. Okay. Now here minus log H plus ion concentration is equal to pH and minus log K concentration is equal to pK. So the equation has come. Now here from this equation we can say that when HCO3 minus ion concentration increases, pH increases. You can see directly proportionate. When HCO3 minus ion concentration decreases, then pH decreases. When H2CO3 concentration increases, mainly CO2. Why? Because this H2CO3 is further converted into H2O and CO2, and pH of H2O is neutral. So when the CO2 concentration increases, then pH decreases because it is inversely proportionate. And when the CO2 concentration decreases, pH increases. Now, what is the biological importance of pH? pH affects enzymatic activity, and each enzyme has optimum pH for its action. And when the pH is above or below this optimum pH, enzymatic activity decreases. For example, if the pH becomes acidic for a long period of time, there is depression of the nervous system that results in coma and death. And if the pH is alkaline for a long time, then excitability of neuron is increased and that results in convulsion. Now, how the acid-base balance is regulated in our body. In our body, two varieties of acids are produced. One is volatile acid and second, that is non-volatile acids. Volatile acids, why are they known as volatile? Because they are derived from carbon dioxide and they are produced during the metabolism of carbohydrate and fat, and they can be easily removed by expired air. Non-volatile acids, they are produced by protein metabolism, and they are sulfuric acid and hydrochloric acid. And whenever there is change in the pH beyond the limit, we have various compensatory mechanisms. They affect and they bring the change back to the normal, and these systems are known as buffer system. Now, so whenever there is change in the pH beyond the limit, various compensatory changes they occur, and that is buffer system. Buffer systems, they maintain pH by binding with free H plus ions. We have three mechanisms. In our body, we have three main buffer systems. They are acid-base buffer, second, that is respiratory mechanism, and third, that is renal mechanisms. Now, let us start with acid-base buffer system. Acid-base buffer system again divided in three types: bicarbonate buffers, phosphate buffers, and protein buffers. Let us start with bicarbonate buffer system. It is present in the extracellular fluid, mainly in the plasma. It consists of weak acid and weak base. Weak acid present in the bicarbonate buffer system, that is carbonic acid H2CO3, and weak base, that is sodium bicarbonate NaHCO3. Now, how this bicarbonate buffer system works? What is the mechanism of action of bicarbonate buffer system? Whenever any strong acid is added in our body fluid, for example hydrochloric acid, this strong acid combines with the weak base of bicarbonate buffer system. Which one is the weak base of bicarbonate buffer system? That is sodium bicarbonate. Now, this reaction, when the reaction is carried out, this strong acid is now converted into weak acid, that is carbonic acid. Now, when strong base is added in the body fluid, for example NaOH, this strong base combines with the weak acid of bicarbonate buffer system. What is the weak acid of bicarbonate buffer system? That is carbonic acid, and it forms weak base, that is NaHCO3. Importance of bicarbonate buffer system. Although bicarbonate buffer system is not very much powerful, but it is important to maintain pH of the body fluid for two reasons. Number one, that is bicarbonate ions, they are regulated by kidney, and carbon dioxide in the bicarbonate buffer system that is excreted by respiratory system. Next is phosphate buffer system. In the phosphate buffer system, weak acid that is sodium dihydrogen phosphate and weak base that is disodium hydrogen phosphate that is Na2HPO4. Now, how this works? Phosphate buffer system is important in the intracellular fluid. Now, mechanism of action: when strong acid is added in the body fluid, the strong acid combines with the weak base of the phosphate buffer system, and the weak base of the phosphate buffer system is disodium hydrogen phosphate. And this strong acid is now converted into weak acid that is sodium dihydrogen phosphate. Same way, when the strong base is added in the body fluid, the strong base combines with the weak acid of the phosphate buffer system, and that is NaH2PO4 sodium dihydrogen phosphate, and it forms weak base that is disodium hydrogen phosphate. What is the importance of phosphate buffer system? Phosphate buffer system is more powerful than bicarbonate buffer, and it is useful in the tubular fluid of the kidney as well as in the RBCs. Next buffer system, that is protein buffer system, which is present in the plasma as well as in the RBCs. In the plasma proteins, they act as buffer because they have carboxyl as well as amino group, and this carboxyl and amino group, they act as buffer. Also because of side chain of the amino acid lysine and imidazole group of the histidine molecules. Hemoglobin is also acts as a buffer. Potency of hemoglobin is 6 times more than that of the plasma. Deoxygenated hemoglobin is more potent buffer as compared to oxygenated hemoglobin because it has more tendency to accept H+ ions. So this we have completed first buffer system, that is acid-base buffer. Next one, that is respiratory mechanism. Now, respiratory buffer mechanism. Lungs, they remove carbon dioxide and they are important in cases of volatile acids. Now here in the tissue, when the carbon dioxide is produced, this carbon dioxide combines with H2O and forms H2CO3, that is carbonic acid, which is a volatile acid as we have discussed, which is further converted into H+ and HCO3- ions. And in the lungs, these reactions are reversed, means H+ and HCO3- ions are converted into carbonic acid, which is further converted into H2O and CO2, and CO2 that is removed by expiration. Third mechanism, that is renal mechanism. Renal mechanism again contains 3 buffer systems, and they are bicarbonate buffers, phosphate buffers and ammonia buffers. Although renal mechanisms, they are slow, but they are most powerful. They have capacity to bring the pH back to the normal. And whenever pH of the body fluid decreases, kidneys, they excrete acidic urine. And when the pH increases, kidneys, they excrete alkaline urine. So this is all about acid-base balance. Thank you.